Good everyone, and welcome to another video of Mr. Faculty Solution. In our last video, we talked about physics and some other cool stuffs where we discovered how to deal with scalar vectors. And the last two, we did mathematics, so we're just soaring on the world of science. But today we're still continuing with physics because I think we still have one or two things to tidy up in that last topic. So we're going to try and finish it up. And when we do that, trust me, we're flying to another world of science and to discover things and uncover to discover. So please do well to like, subscribe, and follow us on this journey as we move to discover more about science. I trust you subscribe to my channel. Please subscribe. Okay, today we're going to be looking at the solution of more than two vectors. Okay, we're going to consider how to resolve more than two vectors. Doesn't matter when it's force velocity. If vectors are more than two, how do you resolve them? Okay, so we looked at how to resolve two vectors. We looked at the parallelogram law and we looked at another way of doing it. So but this time we're going to be looking at how to get the resultant of more than, like when it's more than two, how do we get the resultant? Okay, so I'm going to try and split this board like this, and having done that, you can see that this is going to be my workspace. This is a question. Just assume this is a question, a sample question I just picked that will not it's actually the same way, but I use 30 and 60, so I can easily get their signs and their costs. It could be 40, it could be 50, it doesn't necessarily have to be 30. But for simplicity and for knowledge of their sines and cosines, we have to use these ones. Okay, so we're going to try and create a table. We are going to have F force, which is the force, whatever direction it is. Then we are going to look at that force. How does it affect the x direction? How does it affect the y direction? So when we can get the total ways it affects the x direction, total way it affects the y direction, then we can apply a rule of Pythagoras theorem to finish up. Now, how do we go about this? So we're going to consider each of the force. Let's look at the first force, 5. Now, looking at 5, okay, I would like to use space to some of these artifacts. Let's go fx and fy. Okay, so let's look at the force 5 Newton. What happens? This 5 Newton can be resolved into two components, the vertical component and the horizontal component. So why the horizontal component is fx, vertical component is what? Fy. So I remember saying that because here is opposite, and if you remember the formula, so car, so r, but basically the two we need is so and car. If you look at so and car, this means that sine is opposite over hypotenuse. So if you are looking, if this is the hypotenuse and this is the opposite, to get the opposite, all you have to do, and the hypotenuse in this case is f. Hypotenuse is f. All you have to do is to get the opposite, just multiply the hypotenuse by sine. So in this case, because the angle is 30 degrees, and we are considering only angle in the horizontal, so you're going to be f sine 30, and here will be what? F cos 30. So if we're going to write f of x to be 5 cos 30 degrees, which is 5 times 0.8660, that's 5, we're going to be adding 0, 0, 3, 3, 3, 3, 4, and I think we have it 4.33 Newton. And for the F, we are going to be having 5 sine 30, and we all know that sine 30 is 0.5, so that's about 2.5 Newton. Okay, so then look at the next one. This is the first. So we go like this. The next one is the 15 Newton force. Now we're going to try and resolve this vertically and horizontally. Okay, but with view of this, once you consider the angle it makes with the horizontal, f of x is always cos and f of y is always sine. So in view of that, 15 Newton, let's consider what angle does 15 Newton make with the horizontal. If you can see that this thing is acting vertically already, meaning it has only vertical components. But I would like to prove it to you that actually, in truth, it has only vertical components. So imagine that this is, not imagine, we know this is angle 90. So since here is for cos, we have 5 cos 90 degree, and here we have 15, sorry. Here we have 15 sine 90 degree. So for those of us that don't know, cos 90 degree is 0. So 15 times 0 makes it what? 0. And you can see definitely, okay, and we have to take note that this is acting in the negative part of y, this positive part of y, and this negative part of y. So I have to include the minus sign here. But in x, it is still in the middle, so it's still the positive side. Okay, so you see that definitely that this thing is showing that this force has no effect in the x direction, which as you can see is acting vertically. Where it has all its effects on the y-axis, because sin 90 is 1 and 15 times 1 is what? 15. So it's minus 15. So the entire weight of this force acts on this axis, while on 5, where 4.3 is acting here, 2.5 is acting here. Okay, and then let's look at this, the f of this part. You can definitely see that the 12 Newton force is acting in the horizontal direction, but as usual, I like to give us proof. The angle it makes with the horizontal line, because it's a horizontal line, if you want to consider the angle it makes with here is probably 180. Okay, it's probably 180 definitely. So because 180, you can use its cos, you can use cos 1. We need to come and be 12 Newton, and this one definitely be 0. So I just have to do this one so that we could know why it's that way, but you can see that this is acting only on the x direction. Why this 10 Newton is acting not on any direction, so we have to resolve it. Vertically and horizontally. Now for people who like to follow science as they tell you and not what you think, you could easily do this and try to find out what makes with the horizontal, which if here is 90 and here is 60, here will be 30 degree. And then you can now go back to our f of x is cos. But for bright minds who want to really understand this principle very well, you could actually resolve this way. And thereby f of x will no longer be cos as it used to. It will now take the sine scenario, because we have changed the angle we are using. We're no longer using angle with the horizontal, we're now using angle with the vertical. So definitely they will also swap sine and cos. But for the sake of this class, if you have more questions on this I just showed, you could comment on the video. Please subscribe to our channel. And for the sake of this class, we're going to be considering only the horizontal. So in this case, you can see that this is 10 units. So as usual, we're seeing the result goes with cos. We're going to be having 10 cos 30 degree. With 10 to cos 30 degree is 10 times 0.8, so you have 8.66. And then you have 10 sine 30 degree to give you 5 units, because sine 30 is 0.5. So now what we have to do is to get the summation fx. And when you add all the components of f of x and add the component of f of y, what do we get? Okay, so to get that, this is 4.3, and this we have 12.99. Like I added these two to get 12.99, and then minus this from it, you're going to get 0.99. So you're going to get 0.9. And for this, you have 5 plus this, which makes it 7.5. 7.5 minus 15 makes it minus 7.5. Yes. Okay, so since we know this and we have this, we could finish up. Now to get the resultant force, remember when we talked about resultant force, this is the y-axis, x-axis. To get the resultant force, we said that this line can be redrawn in this way, and that makes it, we can now have y, x, and these are resultants. This is the right angle triangle. To get the resultant, we can use Pythagoras theorem. So let's use Pythagoras theorem that r squared equals f summation f of x squared, which is 0.99 squared plus minus 7.5 squared. So r squared give us, please we can finish this up on our own, find the square root and we could get r. And once we do that, we have actually been able to solve this question. Okay, so for some of our bright scholars, I'm going to leave this for us to finish up. Please let us try and finish this question. It's actually very simple. And then we can now look at the angle. What angle does that first need to be acting? Okay, so we're going to have that tang theta to give us the angle. Because if you are considering an angle, this is resultant force now. You remember this resultant force usually was making an angle with the horizontal, but this is actually had it on. So you place an angle with the horizontal. So if we clean and we draw it this way, it is still making an that angle to the horizontal here is still making an angle. We call that angle theta. So if you want to find theta, this is your opposite and this is adjacent. You know the opposite and adjacent. What combines opposite and adjacent? That's the last one. Two opposite to adjacent. So what's the opposite here? Y-axis, which is minus 7.5 over adjacent 0.99. And when you do that, you get that theta is the tan inverse of minus 7.5 over 0.99. And with that, you have been able to finish the question. But how do you now know what direction to place your force? To place it on, if you have to show it in the this four cardinal points. Now you could see that this is the y-axis, this is x-axis. And you can see that the summation of the y-axis is negative, meaning definitely the y-axis will be acting somewhere around here, not upward, and that for x it's positive. It's positive, and this is the positive side. So this is positive for x, negative for y, meaning our angle will be somewhere around here. So for us, for this, the resultant for this force is going to be located somewhere around here. Thank you for paying attention to this point. I believe that you have learned how to resolve vectors with resolve more than two vectors, and you could actually solve it easy without any stress. Please do not forget to like our videos, subscribe to our channel, comment your questions. Please hit the notification bell so you get notified when I post any video. Thank you. Follow us on Instagram, on Facebook, and thank you and God bless.